As I said in the last video, we will continue to talk about microservice requirements for cross-cutting, and this section we will discuss troubleshooting, which is really critical, believe me. So the first of all, how quickly we locate the root of the issue, root cause of the issue impacts various aspects of our performance as shown below. Background, a number of applications have to call other downstream third-party internal external APIs to get data from non-legacy or legacy systems. That's our requirement, and we cannot change that. Just going to microservices does not change that. Even going to microservices makes it more that our individual microservices call other microservices. How they do it. This backend talks to the numerous other third-party internal external APIs on behalf of the front-end application. A lot of time what happens is we have a front end application, a mobile front end or a web front end made in JavaScript. It could be a single page app, and that app is not expected to call a lot of microservices, so it basically calls API gateway. We talked about API gateway, and that API gateway on behalf of the client, UI client, makes other calls. So that's how it does it. Side effects: engineering teams busy responding to tickets for which the root cause lies elsewhere. It does not lies in the microservice that the engineers are looking for. Is a complete drainage of valuable resources apart from the revenue being lost. Typical use case, a very typical pattern can be seen in client JavaScript application, as I said, that has a proxy or API gateway type of backend. Right, the JavaScript application, as I said, calls the API backend, and the API backend or gateway calls other external or internal microservices or other services to get data on behalf of the client. The troubleshooting challenge in this case is, as the front-end application only knows this API gateway backend, debugging this pair app of front-end and API gateway backend sometimes becomes very time-consuming, often with financial consequences or impacts, and cumbersome without special tools. Real life example: following is a typical scenario when one or more production issues are reported for this pair of front end and API gateway backend applications. So let's move on. Let's see. So origin of trouble. Let's see how the roadmap goes. Customers complain about the application they use, the UIs, and call the customer support. Something probably is they're not finding a store, or their favorite store is not reported, or the hours of operation is bad, or anything else. 24/7 tech support. They receive customer support, customer calls and log support request with the 24/7 tech support. That's what customer support do now. 360 operations. Tech support fails to resolve this lies beyond their boundary. Tech support fails to resolve the issue with their existing knowledge and tool set available. Ticket created. So what does tech support do? 24/7 tech support do? They create a ticket in the ticket system. Tech support reach out to the dev team and create a ticket in the ticketing system. It could be ServiceNow or something else. Let's move on. See what happens next. Dev team manager gets notified by the tech support through email, self-checks, engineer assigned. Dev team manager owns ticket and assigns the ticket to an engineer. Work on the ticket starts. The engineer looks at the request and searches either Splunk logs or Elk logs to retrieve past log data, hoping the incident took place within the time to live established for Splunk or ETL. Normally, because these guys are expensive, I have seen durations of 7 days, 15 days, 30 days, and so you cannot expect to have a lot of logs stored. Even though logs are stored, even though this incident happened pretty recently, logs do not help much, as production logs do not contain debug messages and or request response bodies. Because of the developer, why they do not contain? Because we may be regulated by HIPAA rules or SOX rules, or we are concerned about the size of the logs. If we start logging request and response data, these are huge. So those are the reasons your log may not contain the critical request and response log messages that you may need to debug. The developer start to debug manually, opening his or her ID using user data. Let's move on. Series of denial. Step number 8 takes time, goes in a loop. Almost all downstream system leads claim, because they have their, they have their burden, they have their challenges, they have their milestone. It's quite natural. Claim through email, comments in ServiceNow that the issue certainly does not belong to them. Trust me, this happens. Loss of revenue. If this happens with a critical API where the system company is actually losing money by the hour, developers spend hours and days to fix a non-existent issue and the company still loses huge sums. This is a complete misuse of talent. The immediate impact is that engineers are spending time not by, maybe in a night time, they are not sleeping, not by adding new features, but losing sleep trying to fix a non-existing issue. Lost opportunity this is. This is a double loss of money and development hours that could have been used productively adding features customers want. Features competitors do not have, etc. Losing time like this is thus a strict no-no for smart teams. Let's move on. So what is the alternative? How quickly we locate the root cause of the issue impacts various aspects of the performance as shown below. I have a code example here. As you can see, it's in my GitHub, Rolling Stone debug tool verbose demo. You can take a look. It's a client server application. It completely documents the the scenario in the README and provides a step-by-step process how to run this. Now let's get back to the documentation here. APIs having inbuilt tools. When APIs are deployed along with inbuilt troubleshooting tools, the time needed to shoot real-time troubles can come down to minutes from hours or days. This is not new. The concept is not new at all. From age-old Unix days and current, Maven or Gradle, a lot of command line tools or other tools has a verbose tool attached. When you are debugging, when you want to know what is going wrong, you can just attach the verbose switch and the tool will give you a lot of details for debugging. Can be resolved by 24/7 support teams. If trained properly, 24/7 support teams use these simple tools and resolve and reroute root cause resolution to the correct team without wasting engineering resources from teams. This has a huge dollar value impact in terms of engineer focus and productivity. The simple solution, if the engineering team includes tools such that can be used by the team and support persons to get debug messages and real request response for all the underlying API calls being made to process the troubled request in question, issues where the real problem lies in the downstream system can be identified within minutes, saving time and often without help from engineering. Can be used by business analysis. Business and product analysts can use this tool without being tightly coupled with engineers. So probably the engineer is on vacation, he or she is not available, so anybody can use it, right? That's the idea. The development dollars are better spent. If it is suggested that engineering teams keep a dashboard for monitoring how many hours the team has spent on troubleshooting efforts and works on to reduce the hours when the issues was with someone else. Security, any such tools though that expose underlying functionality, request response and API calls made by the customer facing application needs to be disabled for the external world. This can be done in the CDN layer, that anybody calling with an API with that additional verbose parameter need to be stopped at the CDN layer. This cannot be entertained. This is for internal resources. This is not for the public. Let's move on. This is a new section, so I would rather create a new video or new lecture for this, and let me stop here. Let me know if you have any question. Thanks for listening, and I will see you in the next video. Thank you. Bye.